Hi there. In this video, we will show you how DCIDE may help you to conceptually design single line diagrams faster. Before DCIDE existed, we used to spend a lot of time in conventional drawing tools, like the one that you see on the screen, in order to get an idea about a microgrid or an electrical power system across to our customers and colleagues. We found ourselves, for instance, creating a single line diagram where we had a connection to the grid. To resize this and snap this grid, where we used to connect an AC-DC converter. We wanted to show also that there's a separation between there. To connect that, make it bidirectional. This, right? And then we went on to a DC bus, for instance, like this. I try to connect this. And on the DC bus, we would then connect. Let me copy, paste a battery. That means of a DC-DC converter. Again, converter. Then we want to indicate that we have bidirectional power flow. Then our battery. Right. This battery. And this is, let's say, a 700 volt DC bus. So let's enhance this drawing with some data. So let's say the grid connection is like 400 volts DC, and I'm going to call it grid 1 as a component. Another text box below it. AC. Align this. And let's say our grid is like maybe 63 amps. And then we have our converter, which is like, let's give it a designator E1. Let's give it a power level. Let's say we go with 30 kW. Okay, we have a 700 volt DC bus. We have our battery here with its own converter, DC one. That's maybe a little bit more. We can make this like a 60 kilowatt converter. And let's then add our battery. So that one. Another shade below that, which is like, let's say 300 kilowatt hours, like this. All right. And let me now insert some protection device. Let's say I want to add a fuse here. So to shift this down. Right. Add another component in between here. Add a little bit more space. Like this. Connected. And then this is our fuse. Let's say this fuse is like a, let's say this battery is maybe like 600 volts nominal. Then we need about 100 amps nominal fuse here. So you'll see, actually, I spent like close to 5 minutes actually to generate this drawing. And primarily, I always felt myself be more wondering about how to connect the blocks and the lines together and how to make them align properly. Like here, for instance, there's a misalignment. That's not very clean. So I have to go and move that anchor or move these parts like this. And then I forget to take a label with me and it's not properly snapping in. So actually, instead of me thinking about how things electrically should go together, as I'm brainstorming, I am actually more wondering about how to get my ideas on paper. So that was one of the primary reasons why we developed DCIDE, which I'll show you in a minute. It's a software that helps you design these single line diagrams at the speed of thought. Let me show you how that looks like. So let's switch over to DCIDE. So in DCIDE, you'll notice we have like a canvas as well. We have all of the symbols already made in there that you typically find on electrical diagrams. So we have the icons in there. That's also something that we're lacking in the conventional tools, although you could argue you build a library for that. But we have made it industry specific. So if I want to draw the same thing, so I have a grid connection, of course I have to select my preferred measurement system. I will connect that grid to an electrical bus. I'm going to convert it from 400 volt AC to DC. This is my 700 volt DC bus, like this. I label it. And we have our battery in here. And we have our DC-DC converter. So effectively in less than a minute, I actually get a diagram sketched out. And I'm now completely designing in the electrical space. If I want to specify these components, I can go to the right, can select like a 400 volt AC system in here. I can specify that my DC bus needs to be like a converter that ties AC to 700 volt DC. You'll see also that there is a product library in the background. So as soon as you enter specs in here, you get components suggested that may fit into your design. It's pretty remarkable too. And our battery system, I think this was 300 kilowatt hours. So we show that it's a 600 volt battery in here. Our converter was a 60 kW, if I'm not mistaken, like this. And you'll see as I enter specs, my design gets nicely annotated in there. All the lines are properly aligned, the blocks are nicely structured. So this is a nice presentable format that you can use to get your ideas across to your customers, your colleagues, whoever is involved in a electrical project effectively in there. This is really built for the early stages of a project where you literally start from a blank sheet and where you're trying to get the main concept put together with your customer, with your colleagues and others. And then in our other drawing, we were about to add a fuse. So let's do that here too. So I just drag that one down and I can just drop that fuse in place. It nicely inherits the specs. This was a 100 amp fuse. And again, we get components suggested that might fit into this design easily. So this is what, in our view, designing at the speed of thought looks like. You remain in the electrical mindset, as we call it. You're not wondering about how the blocks should align and how you can connect those together. No, you really think about these blocks as actual electrical components. And that's what we spend a lot of time on to achieve that drawing experience. So if you're interested in trying this out for your electrical power concepts, for your single line diagrams, you can visit DCIDE.app, and that I can quickly put in here. You can create an account over there. Just enter your email. You can get started for free. You can start drawing right away. And the nice thing is this software runs online in the cloud, so you don't have to install anything offline to get started. Just visit DCIDE.app and feel like what drawing at the speed of thought looks like.